Okay, so I am recording. I've got still some more stuff to do. Got to connect to the internet. Let's kill one more set of lights. Do you mind over there? Try the middle one. Is that okay? All right. All right, so before I get into the syllabus and everything else, let's see what those little clickers are. All right, you've got these little clickers are designed to allow you to answer a question without actually having to raise your hand and maybe be embarrassed, you know? So like I'm like, do y'all understand what I'm talking about? And if you don't, you hit 2. If you do, you hit 1. So A is yes, B is no. See it on here? The rest of them we won't really use. You can change your mind, like if you say, okay, now I get it, you can click it. So let's just do a quick poll. Everyone click yes, so click A, or 1. And you can see here, we've had 18, 19 responses. 100% of you said that, okay? So, And so now, if I ask a question, let's see, how many, if you're a girl, hit yes. If you're a guy, hit no. So that's our ratio, roughly, 2/3, okay? You see how this works? All right. It's not connected to you in any way, so I'm not going to know, like, be able to go back and say, okay, I knew exactly what you were saying. You were the one that kept asking the questions, you know? It's just totally anonymous. Just don't walk away with these because I'm responsible for them. So at the end of class, I'll ask that you just bring them back up here. All right. Some of you are changing gender as we... Okay, next order of business. We'll get back to polling because I want to know a little bit about you, but we'll get to that in a second. Can we shut the door? Mind? I don't like to have the door open. So these days you have to be concerned about the possibility of someone deciding they're going to come here and try and kill a bunch of us, right? Walk down the hall and shoot a bunch of people. Can't worry, but you have to be prepared, right? Have you ever heard of that that saying, like, luck is preparation meets opportunity? Something like that. So you can't freak too much out about it, but in the event that something like that were to happen, you got to know what you can do and where you can go. So I just want you to know that out this window is a pretty big drop, okay? So this is not a very good option for us, but it is probably survivable. Because there's like, it's only a 2-story drop. It's not all 3 stories, but it's onto concrete. So just know that that's, last resort. That's where you go. Now there's also exits over there and stuff like that, but. What's that? You think so? Okay. Well, hopefully we won't ever have to worry about it, but, that's then if we go to room 309 next time, there's a nice little like covered thing and we can jump down to it and run off and it's much safer. But okay. I know you already think I'm like paranoid. All right, this is Northwest Vista's main website. Hopefully you've all been here. I clicked on log into ACES, right? Takes you here. And how many of you have already done this? Like know what's going on here? Yes or no? Where's my polling thing? Where'd it go? How many of you know how to get into ACES? All of you? All right. Good enough for me. So I'm assuming you can log in. Once you're logged in, go to courses, and then you should be in summer 2015, college algebra right here. So I'm teaching 4 classes this semester. 2 of them are internet classes, 2 of them are face-to-face. I'm only here on Tuesdays and Thursdays. So I teach Calculus 2 at 9 a.m. and it goes till 12:40. From 12:40 to 2, I have a break. So I'm going to be in my office from 12:40 to 2. So before our class, if you need to come and talk to me about homework or anything else, I'm there. All right, that's where you can find me. I'll show you, I'll tell you where my office is and stuff like that. All right, so this is our main page. This is officially the way we communicate with each other. If I want to send something to you, it'll be through here. If you want to send something to me, it needs to be through here, not through your Yahoo account or anything like that. So there's an inbox over here. I have something in my inbox. It wasn't there like 10 minutes ago. So I've got a question from an internet student, and if I want to send an email, I click on compose a new message. I select which class, so you would select 1314. You would select the person you want to send an email to, in this case the teacher, which is me, and then you type in your email, and you can put attachments in here. You can even do a webcam video. No one's ever done that, but you can. If you want to like show me you broke your arm or something. I broke my arm, I'm not coming to class. Okay, so back to the class. We're going to go through the syllabus first. This is our official contract, all right? This is the way the course is going to go. I won't deviate from this unless I change it here and I let you know. And you should know what the expectations are. I didn't introduce myself, sorry. Robert DiGiovanni, and I've been doing this gig for a long time. So I'm a full-time instructor here, but in the summers we act a little bit more like adjuncts because we're not here full-time. This is the first time I've taught 1314 in a long time. It's been a long, long time. So usually I teach like the 1414, the calculus, and things like that. So that doesn't mean I'm harder. I'm actually relieved to be in 1314 because it's actually, to me, this can be fun because this is the end of math for a lot of you. And I'm not sitting here going, you're going to build a bridge one day, you know, like I want to be able to go across that bridge and know it's going to hold, you know, it's like, it's a little different. So we can just relax and take our time and try and enjoy it a little bit. Understand? So we meet, you know, we meet 2 to 4:40, right? Twice a week. And my office is way down. I'm sorry, it's hard to read this. My office is in this building, way on the first floor, room 111, office O. That's an O, not a 0. So you go into room 111A, and then once you get in there, the offices are on there. You can find me. There is no textbook required for this class. Okay, what they did is they created a packet that we are going to go through. And I should mute this because I've never used this packet. I've heard good things. I've heard bad things. We're going to just have to see how it goes. So the pro is you don't have to buy a textbook. The con is you don't have a textbook. You don't have like what a textbook has in it, all of that information. But students usually don't read the textbook. So, you know, we'll see how it goes. I'll show you what you will need because there's a packet. You have to print things out. That's why I asked them how much it was to print. Some of you weren't here. They talked about the services available and stuff. You also are supposed to get a calculator. This TI 30XS calculator. I didn't know that that was required until, oh, I didn't tell you. I wasn't going to teach this class. They changed the instructor. What happened was, sorry, some of you were trying to avoid me and you had no choice. The instructor, what honestly happened was the class I was going to teach didn't make. Not enough students were in it. So because I'm full-time, I got the opportunity to take a class from whoever. Well, any of the part-timers. So Joanne, yes. So I didn't say who's teaching. I just said what classes at this time on this day. And they told me here are the classes, and I said I'll take that one. So that's what happened, unfortunately for her. And sorry, you look disappointed now. So this, I wasn't aware that this was a requirement. Anyone buy that calculator yet? How much is it? 20 bucks? Okay, since there's no book, let's just say that let's go with that. Okay, where'd you get it? Bookstore? You probably get it at Walmart for cheaper. 17. Okay, so you don't have to buy a textbook, but you have to buy a $17 calculator, $18 calculator. That sound good? That way we're all doing the same thing. The keystrokes are all the same for all of us. Let's try and get that by Thursday. If you really can't get it by Thursday, let's say Tuesday, absolutely you have to have it. Bring it every day. All right. You're also supposed to have a binder because you're going to have notes, like a packet, and so you need to keep it somewhere. And so get a binder. I actually printed the first packet of notes for you, but I forgot to 3-hole punch them. And after they printed, I was like, okay, so too late. But you can go, to the library and just use their 3-hole puncher. Put this in the binder. Keep everything together. Put all your homework in there, all your quizzes, everything that you've got. Just keep it all nice and organized. All right. So a description of this course. We're just getting the basic college algebra skills out of the way, right? That's it. I'll let you read through this because you can read. Same thing with objectives and outcomes. Let's get to the grade. So we're going to have homework, which is going to, it's already in all the packets, already have the homework right in them, right? So you do the homework, that's 10% of your grade. And I'll collect those probably on the days of the exams. You'll come in, you'll give me your binder, and I'll thumb through it while you're taking the test, and I'll check to see that you've kept up with your homework. But that doesn't mean do all your homework the night before the test. That means you've done the homework, and now you're showing me you've kept up. And then I will also give quizzes over the homework. So I would anticipate every class you come in, there will be a quiz. It'll be over something from the homework. So if you did your homework, you should be good. If you didn't, then you're going to struggle. So the quizzes will be 15%. You'll have 3 exams, each one equally weighted, total 50%, and then 25% for your final. Questions on that? Exam 1 should cover just the material that we've done up to Exam 1. Exam 2 should be the stuff after Exam 1 up to Exam 2. Exam 3 is everything between 2 and 3. And then the final would be some sort of comprehensive, it'll cover everything, but it won't be like, 1,000-question test. Just the major points. Tutoring, there's tutoring over there across the way, and there's tutoring over here. There's a difference between the 2 labs. I believe that one will only help you with developmental topics, things that we cover in developmental classes. They'll help you, and I think you get 3 face-to-face visits with them, 30 minutes each, face-to-face, one-on-one tutoring. The other one is more like you sit around, raise your hand, tutor comes by, helps you, and then they leave. So make sure that you're aware of their hours. Go on to the doors, and they have their hours posted. See when you can get over there and get help, all right, if you need it. Attendance, you need to be here. You may be withdrawn from the class for excessive absences. In a summer class, that's 2. So you can miss twice, no questions asked, that's fine. After 2, it becomes an issue. You could be dropped from the class, all right? And I will take attendance using this. I will pass it around. Your name should be listed. The date, you just go down, initial it, and then pass it around. This needs to get around to everyone in the class, all right? And we'll start today. If your name's not on there, just let me know at the end, and we'll figure out why you're not there. Now, if you decide that you don't want to be in this class anymore and you stop showing up, do not assume I will drop you, all right? So don't just say, you know what, I went the first week, not working for me. I wish it was Joanne, and then assume I just withdraw you from the course. I may not withdraw you. I may just, at the end of the semester, you have zeros, and so you get an F. And that's only because you need to know that in a big university, that's the way it works. They're not going to sit there and go, okay, who's here, who's not. You just stop going, you just get zeros, and then you get an F. So if you don't want to be here, make sure you withdraw yourself from the course. It's your responsibility to withdraw. Now, withdrawing is a lot easier than it used to be. You used to have to like go and get a piece of paper and get it signed. Now you just send me an email, say, I want to withdraw, and I drop you from the class. It's that easy. 6-drop rule. Back in 2007, the state realized that people were going to school, getting financial aid, and not going to class, and just living off of financial aid. I can't believe that Americans would do that. But yeah, so they instituted this thing called a 6-drop rule, which means that if you're in Texas, you are allowed to drop 6 courses throughout your entire college career. 6. That's all right. 6 courses. After that, you must start paying out-of-state tuition, which is substantially higher. And so it's kind of a penalty. And so just be aware of that, all right? 6 drops are all you're allowed. SOBI, this has to do with all of the issues that you might run into with, people that are kind of odd, or I don't know. You notice someone, they just don't seem right to you, something. Personality issues, just reporting things. You read through this, all right? Common sense stuff, right? You don't want to be that person standing in front of the newscast. Well, I kind of had seen that they had this, shotgun in their backpack, but I didn't really say anything about it. This sort of thing, the obvious stuff, pay attention. Value of associate's degree. Here's our schedule. Here's the day-by-day. I have a better schedule than this. I have to put it in the syllabus, but I'll show you a better version of the schedule in a second. Everything after that is stuff that has to be in here. I have no control over. So you can read through all the institutional policies. Now, there's something in the syllabus I forgot to put in there. So I'm going to add it in there. And let me show you what it looks like because it's in my other syllabus. This is my Cal 2 syllabus. There we go. Electronic devices policy. So you don't need a laptop in here, so I'll scrap this. But here's the big thing. Any electronic device that you're using to like update your social media status or surf the web or text your friends, it's not allowed. So you can't have your phone sitting there. And don't try to be that person that thinks I don't notice you doing it, because it will cost you a 10% penalty on your next exam, which is an entire letter grade penalty. You'll be asked to leave and you'll be counted absent. All right? Does everyone understand that? All right. Now, if you're expecting an important phone call or, just let me know ahead of time. Hey, I've got some stuff going on. I'm expecting a call. I need to be able to get it. That's fine. Just don't answer it in here and start talking. Take it outside. I have no problem with that. If you do need to go update your social status, let people know how much suffering you're doing in college algebra, take it out of the room, do it out there, come back, okay? Just not in here. I find it very disrespectful. And same thing with behavior. Sleeping. Sleeping is also something I don't tolerate. So if you're really tired, you had a long night, and you're doing that nodding off thing, get up, go walk around, take a nap on the little chair out there for 15 minutes, come back, just not in here. All right? Any questions on that? All right. There seems to be like a lot of issues with this one. It's like, I'm in college, I'm paying to be here. How can he tell me I can't have my phone out? Well, right now they do allow me that freedom to have rules in my classroom, and that is my rule. Until they take that away from me, that's what it'll be. All right? scholastic dishonesty. This has to do with cheating. I mean, sometimes we can actually get a good rapport going in here. We're all kind of like having, I don't want to say fun, but we're like, we're doing okay, and everyone's kind of becoming friendly with each other. And then we take a quiz and you forget, you know what, that talking, that camaraderie you have has to stop right there. And you have to do the quiz on your own. You can't help each other. If you're cheating, the consequences are an F. That's it. There's no other, there's no like middle. If it's anything I say you're supposed to do by yourself, you do by yourself. That's it. And especially with these seating arrangements where you're facing each other, I mean, it can be very challenging to not look up, and you know, so you've got to not only keep your eyes on your own paper, you need to protect your own work from other people. All right. All right, I think that's it with the syllabus. Let me get back to this. So I said I had under the syllabus a schedule. The schedule, you can download it, and it's a PDF file that you can open up. It's a little easier to read. So day one, today, the 9th of June, we are going to cover, oh, wait a minute, hold on. This is my calculus class. Yeah. Oops. Here we go. There we go. So day one, we're going to cover fractions, order of operations, simplifying linear expressions, solving linear equations. This is all supposed to be review. In fact, we're going to be reviewing quite a bit of stuff. At some point, it should probably become somewhat new to you, or it might be something you've seen that we go into a little more depth than you've gone in the past, or maybe something that you've seen already and you're going to survive, you know, easily through the first, you know, 2-3 tests. It just depends on your background. If you did any of the developmental classes here, like if you got all the way up through 320, then a lot of this course is going to be okay for you. Any questions on how this works? When's our first exam? What is that? The 30th? And it'll cover days 1 through 6. And it looks like we have the entire day for the exam. So it'll be kind of long, but I doubt it'll be the entire time. In my Cal 2 class, we take an exam for the first half, and then the second half we continue lecturing. We're not doing that in here. Just the exam, you're done, you leave, you go home. All right? Looks like quizzes almost every day. And then the final is the last day of class. Questions on the schedule? All right. Once I'm done recording this, I upload it to YouTube. I'll do it usually right at the end of class. It usually only takes about 2 minutes to upload the video. It usually takes YouTube about 30 to 40 minutes to actually process it and put it out and make it available. So, you know, usually by the end of the day, you'll have the video. But once it's there, you can click on class lecture. Whoa, why'd that go here? What the heck? That's not correct. Sorry, I never updated the link. Let me do that real quick. Try this again. Okay, so once you click on class lecture videos, it'll take you to YouTube, and you're looking at a playlist in YouTube that is called 1314 College Algebra Summer 2015. And the videos will start to appear here as we get through the days. If you don't want to have to go through Canvas, then you can just go to YouTube and you can search Robert Math Guy. And then if you see this thing up here, you'll see a little icon, you know that you've got to the right place, all right? And if you wanted to, which you probably wouldn't want to, you can go and look at all my playlists, and it has all my lectures from like the last few years for all the different classes. So, yeah. All right, questions on that? Files. So I said you've got no textbook, you've got these packets. So when you click on files over here, you'll see the schedule, which is the one I showed you that shows you kind of day by day. You can get to it this way also and download it and print it. Miscellaneous. There was a bunch of stuff. I don't even know what happened to see. Joanne had this in here. There's a bunch of stuff, and I'm like, I was a little bit overwhelmed. So I just made a folder called miscellaneous, and I put it in there, and I said, I'll figure out what the heck all that was about later. Student packet files is the most important thing for you. Student packet files. There's what, 4 packets, right? The review packet is packet A. I printed the entire packet for you. It's 28 pages. Packet B, I will not print for you. You need to bring that to class. And I believe we're probably going to need it next class. So try and get that as soon as possible. You could go to the library and print it. They said that you can create an account. You have to add money to the account, so you probably need a credit card, and you can print it out. They said 8 cents per double-sided copy. So let's see how many pages this one is. "68 pages. So divide that by 2, because it's double-sided. So 68 divided by 2, 34 pages is what you'd be printing at 8 cents a piece. So what would 34 pages at 10 cents a piece be? $3. So it's going to cost you less than $4 to print that packet. And each packet's probably about that. So it's not going to cost you more than 15 bucks probably to print everything. And the calculator, the whole class for under 30 bucks, 40 bucks. Plus the tuition, I guess. But that's if you do it that way. If you have a printer at home, you can do it that way also. But just know that there are options for you there. All right? Questions? Now it says packet test 1 material. That means that that packet has the stuff from for test 1 on it. And along with the review. The review material could be on the test 1 also. Packet 2 is going to cover everything up to test 2. And then packet 3 is everything up through test 3. Understand? Okay. I don't believe there's anything else here that I want to discuss. I'm going to turn a little bit here. Start to get nauseous going like this back and forth. There's a discussion board. If you want to discuss things with your classmates, you can. Your grades, as we get them, will appear here. People is a way you can find classmates, email them, hey, you want to do a study group, something like that. Files, you already saw. Attendance, I need to take that out of there. I'm going to do attendance with that sign-in sheet. Anybody not get the attendance? Okay. So. All right, is there anything that you all want to discuss before we get into this? No? All right, let me hand out the packet. So take one, Pass them back, please. All right, so everybody is signed in? Extras? Thank you. If there are any other extras, just leave them on the desk and I'll get them at the end. All right, so let's just take a look at the packet just to give you an idea of how this works, and then we'll start going through it. So this review material, as you can see, it has kind of like definitions, shows you what properties there are, then there will be an example, then more kind of explaining things, and then more examples, then more examples, and eventually you get to homework, right? What page does the homework start on there? Page 5. So you've got material, and then you get to page 5, and there's your homework set. Now, if you can fit your work onto the page, that's fine. I'm not a big fan of doing your homework on here because I don't think you should ever restrict yourself to a little 2-inch by 2-inch square to try and do math in. So I encourage you to just do all the problems separately. There's a lot of homework. Look at that. How many problems are on that homework set there? 25 problems. See that? 25 problems. And then the next section begins. Topic is order of operations on page 9. We cover that in class. We go through that until we get to page 15, which is the homework for that topic. And that homework topic has another 25 problems. Then another topic on page 19 of linear equations. Examples, and then homework starts on page 23, and homework ends on page 28, right? Make sense how the packet works? Okay. Remember, there's a big asterisk here, right? Big old asterisk. I've never used this packet, all right? I don't know how this is going to go. You're going to have to give me feedback and let me know what you think, all right? My idea is to do this. So let's start. Let me show you what I plan on doing. So this is review material. We're going to start with fractions, right? The topic here is fractions. And the things we need to remember about fractions: only the operations of addition and subtraction require a common denominator. So hopefully you remember that whenever you have two fractions, you want to add them or subtract them, you have to have the same denominator in order to achieve that operation. You can never divide by 0, all right? When changing division to multiplication, remember we invert the divisor. So if you take a fraction, a over b, and divide it by c over d, you change the division into multiplication, and you flip the second fraction over, and then do multiplying. And then always remember to reduce your fractions. So reducing rational expressions, the key step here, reduce by finding a common factor. So we're going to start with this first example, 18 over 12. So I can draw on this, and maybe you can write on yours, right, and do what I do, and we'll see how this works. So it says find a common factor. So when you look at 18 divided by 12, what is a common factor? What does it mean, common? 3 goes into both 18 and 12. 6 goes in, right? 2 goes in. So those are all common factors, right? I can use any of those. So let's start, what was the first one I heard? I don't remember. Let's say 3. Let's say you use 3. How many times does 3 go into 18? 6 times. So 6 times, and how many times does 3 go into 12? 4 times, so we get 6 over 4. Now, is that a completely reduced fraction? No, because something goes into both of those. In this case, 2. So how many times does 2 go into 6? 3. How many times does 2 go into 4? 2. Now, is this reduced? Yes, because there's no more common factors other than 1. 1 is the only number that goes into both. So that would be, okay, so let's talk about this. This right here is called improper fraction, right? Improper fraction. So there is another way you could write this in what's called as a mixed number, right? Mixed number. So let's talk a little bit about mixed numbers. For a mixed number, what you do is you say, how many times does, well, let's do it this way. You do like the old school division like this. 3 divided by 2. How many times does 2 go into 3? 1 time. So it goes in, you put a 2 under here, you subtract it, you're left with 1, right? That's your remainder. So you write your 1 and then your remainder over your divisor, which was 2. So 3 over 2 becomes 1.5. Are we familiar with that? Okay. It's going to do something here. Where's my little polling guy? Okay, so if you are okay with this, then this answer could also be written as 1.5. Both answers are correct. Now, let me just tell you from the perspective of a person who teaches, beyond this math class, we would say absolutely forget about 1.5. This right here is kind of like, you remember if you want to do multiplication, you do 3 times 2. If you want to do division, you can do 6 divided by 2. Like that's notation, right? But we stopped doing that at some point. We write 3.2, and instead of 6 divided by 2, we do 6 over 2, right? Do these mean the same things? This is what you learn when you're in grade school. That's the notation, right? And then as you move on in math, you go to a different notation because you're advancing. Same thing with this. Improper fractions are used as you advance through. Mixed numbers are more basic, more elementary, more grade school style. You should be comfortable with both, but really this is the preferred. I wouldn't count it off if you did this though. Now, I'll explain why, all right? A lot of people don't realize what 1.5 means. I mean, you understand like 1.5 candy bars. Everyone understands that means a candy bar plus another half, right? But as far as the operation here, this is actually 1 plus a half. And not many people realize that's what it really means. 1.5 means 1 plus a half. So why not write just 1 plus a half? Why write it this way? It can be confusing. Some people can think you mean multiplication here. So it's kind of like an older notation, that not an older, but just something we avoid as we get higher. I hope that addresses your concern or question. I don't think you had a question. You just wanted to know if you wrote it the other way, right? See, that's why I love 1314, right? We just want to get through it. We don't need all the background and history on it. Just tell me what you want to see, right? Either one.
And if I come about it a different way, like I didn't go through the exact steps you did,
that's right.
Get it, you're still fine with that?
That's correct.
I don't need to show you 35 steps if I know that 3 goes in there?
That's right. Now, I said let's do 3 went into each one, right? and then we got 6/4, and then we said 2 goes in each one, we got 3 halves, and we were done. If you would have at the very beginning just said 6 goes into both of those, you would have been right to 3 halves, and you would be done. And maybe you can just do it in your head. That's fine. I'm not going to take off for that. But we need to understand what we're doing, right? Okay, next thing, adding and subtracting rational expressions. So in order to add two fractions together or subtract, we have to have a common denominator. If we can get a common denominator, all we have to do after that is add the numerators up and keep the denominator the same. So we're going to do this example right here, 1/4 plus 5/6. We have two fractions being added together. Do they have the same denominator? No. Since they do not have the same denominator, I need to get a common denominator. So I need to find a number which is a multiple of both 6 and 4, a common multiple. What's that? 12. Why not 2? 2 goes into both. 2 is a common divisor of the 2, but not a common multiple of the 2. For a common denominator, you need a number that both of them go into, not a number that goes into both of them. Understand the difference? So we're trying to find a common denominator. I heard what, 12? Would that work? Right? 4 times 3 is 12. 6 times 2 is 12. So 12 would work. Is 12 the only common denominator? No. What's another one that would work? 24. Any number that's a multiple of both, right? But we like to try and find what we call the least common denominator, which is the smallest number that's a multiple of both. In this case, that would be 12. So once we're here, once we have a common denominator, what we want to do is transform the problem. Now, notice when I rewrite this, I left a space in front of the 5/6. And the reason why is because what I'm going to do is I'm going to multiply 1/4 by something to create a 12 in the bottom. So I have to multiply 4 times 3, right, to get 12. So I multiply the bottom by 3. Whenever you multiply the bottom by 3, you have to multiply the top by 3. Why is it that you have to do 3 on top and bottom? Because what is 3 over 3? 1. What's 1 times anything? Itself. So we're not changing what it is, right? 1/4 is still going to be 1/4. It's just going to look different. So I'm going to multiply that. That'll give me a 12 down here. Up here, I'll get a 3. Here I need to turn 6 to 12, so I multiply the bottom by what? 2. Whatever I do on the bottom, I must do on the top. Same principle. We're just coming in here with they're like hidden ones, and we're like making those ones look different in order to manipulate the problem to have the common denominator we need. So now do our little multiply, 3 over 12. So this becomes 3 over 12 plus the next one, which is 10 over 12. Now that they have the same denominator, we are free to add them together. And how does it work when we add these? You put the two numerators together, 3 plus 10, and we add the two denominators together? Why not? We're not supposed to, right? Don't ask me why, right? You don't want to know why, right? You just want to know if you're supposed to or not, right? You don't. You don't do it. I'll explain why, and it'll hopefully make sense, but the denominator stays the same. That only happens in addition and subtraction. 3 plus 10 is 13 over 12. And that is your answer written as an improper fraction. Now, if you'd like to go to a mixed number, it would turn out to 1 and a 12. I don't care to see a mixed number. I don't need to see it. But if you like them, I'm not here to make you unlike them. Questions? No? You come in? We have. How's it going? Yes, it is. 1314. You're what? Okay. What's your last name? All right. Come on in. You can actually take this chair and that desk if you'd like. Just make sure you can see up here. And then also take this in initial that you're here. All right, so there, we're done with that one? We're good? Oh, why is it that we had to Keep the denominators the same.
The whole,
You,
right?
right?
It represents part of a whole.
Yes, if you have like 1/2 plus 1/2, right? 1/2 plus 1/2, you should get 1, right? Half a candy bar, half a candy bar, you should get a whole candy bar. So it makes sense that you should do 1 plus 1 over, keep it 2, and that would give you 2 over 2, which would give you 1. If you added them together, if you added everything across the top and everything across the bottom, this bottom would become a what? 4. So you get 2 over 4, which would be a half. And so you're saying 1/2 plus a half is a half? That doesn't make any sense. So it has to work that way. I know that's not a great explanation, but at least you can convince yourself that it doesn't work that way. All right, next one. 1/8 plus 2/5. What's our common denominator? 40. Now you can always multiply the two denominators together, and that's always going to be a common denominator. 8 times 5 is 40. The question would be, is there a smaller one? How can you figure out if there's a smaller one? There's not, but how could you do it? That's right. You write down the multiples of each one. What are the multiples of 8? 8, 16, 24. You keep going, right? What are the multiples of 5? 5, 10, 15, 20, 25, 30. And you're looking for the first number that appears in both lists. In this case, 40 would be the first one. So I'm going to turn them both into 40s on the bottom. So I get to come in here with my special 1, right, for each one. What's my special 1 that I'm going to come in with on the 1/8 here? 5/5. I'll do it in red. Little dot between them means multiplication. And then over here, 8/8. All right, and sorry, this right here is just going to get moved a little bit over. And what do we get? 5 over, these multiplied 5 over 40 plus 16 over 40. So now we're at 5 over 40. Wow. 5 over 40 plus 16 over 40, which is 21 over 40. Now we need to make sure that that can't be reduced. Is there a number that goes into both of those? No. How do you check? I mean, you have to mentally do it, right? You have to say, okay, does 2 go into both? No, because 21's odd. Does 3 go into both? No. 4? No. And you have to just go through and exhaust the numbers until you feel like there's nothing else. So we're done.
So if it could be reduced and we didn't reduce it because we didn't notice or whatever, you're going to count it wrong?
Not the whole problem. The whole problem would not be wrong. It would be, you know, if we say that each problem is worth 10 points and you didn't reduce, you'd probably get 8 or 9 points out of 10. It's not incorrect, right? I mean, if you go up to HEB and order half a pound of ham, and say, can I have 16 30-second pounds of ham? And they're going to look at you like, what the hell are you what are you talking about? 16 over 32 is the same as 1/2, right? It's the same fraction. So it's technically not incorrect. But if we're saying reduce all fractions and you're not reducing them all, then it's not what we're asking for. All right, next problem. 5/9 minus 1/6. Common denominator. 18, right? 18 is actually the smallest number that's a multiple of both. I think on this one I'll show you the list quickly. The two denominators are 9 and 6. So I list out the multiples of 9. 18, 27, 36. I could keep going. 6, 12, 18, 24. And so I'm looking for the smallest number that appears in both lists. That is my least common denominator. So that's why I'm coming up with 18 for this one. So let's turn 5/9 into something over 18. I have to multiply the top and bottom by what? 2. So I'm going to go 2 over 2 times the 5/9 minus this time, right? Minus. How do I turn the 6 into 18? 3. So 3 over 3 times 1/6. Man, see, this is why I don't like the packet kind of forcing you to do all your work in the packet. I don't think that that's a good idea at home. It's a lot of information to force into a small space. Okay, let's go ahead and put those together. What is that? 10/18. Then what? What do we have here? Minus, right? Minus 3/18. See, this is the first one where we have subtraction. So you, instead of doing 10 plus 3, we're going to do 10 minus 3. What's 10 minus 3? 7 over 18. Can that be reduced? No. 7/18. We're done. Questions? All right. Does it seem warm in here? Is it warm? 3 o'clock. Let's see what this thing says. It says 73.8. I highly doubt it's 73.8 here. All right, so we've got your mixed numbers. How do you add mixed numbers? You make them improper fractions, and then you do everything you just did. Now, another way is to add the 8 and the 3 together, and then add 2/9 and 2/3 together separately. But you run into danger when it's subtraction. So I think the best rule of thumb for you, if you want to stay safe, is just convert everything to improper fraction first. So how do you take a mixed number and convert it to an improper fraction? So you take these two numbers and multiply them. 8 times 9, 72. Add the 2 up here, which is 74. And then you put that over what? 9. So we have 74 over 9 plus, same thing. Multiply these two together, 9. Add 2, 11 over 3. Okay, quick poll. Understand? Yes. Don't understand? No. So yes, yes is 1. 2 is no. Do you understand how to convert a mix to an improper? We have 100% of the 20 people who are voting understand that. Good. Now, if we want to add these together, we need a common denominator. 9, right? Could we have used 27? Sure, but why? Because 9 is already the least common multiple of 9 and 3. So I'm only going to need to convert this first one over. So this is equal to, the second one over. What do I multiply the top and bottom by? 3 over 3 times the 11 over 3. So we have 74/9 plus 33/9, because we did this multiplication here, which is 107 over 9. Does anything go into that? Three, maybe? Does 3 go into 107? No, it doesn't go in there. You could check it on your TI 30X that you're going to buy, right? Oh, hey, what do y'all think if you have how many of you already have a calculator that you're happy with? All right.
You can download an app like that calculator on your phone, right?
Yeah, but you can't use your phone on a test. Yeah. That's what?
I mean, that makes sense.
Yeah.
Sorry.
Yeah.
I didn't think about that.
Yeah. I mean, so, that's a lot of you that already have a calculator. All right, let's take a poll. How many of you think that I should require that calculator? Yes or no? Vote, please. Okay. I think that's a majority. So what we'll do is you must have a calculator, okay? You must have a calculator, but you are not required to have the one that's on the syllabus. That fair? You do not need a graphing calculator. But see, there's someone who already has a $100 calculator. I'm not going to say, now go buy a $20 calculator. It does less than what yours does, you know? Doesn't make sense. All right. Next one. We're almost done with these. What is this first one converted? 7 3/5. Converted over is 38/5 minus the next one converted over 7/2 or 7/2. What's your common? 10. You multiply the first one top and bottom by what? 2. What's 2 times 38? 76 over 10 minus, I need to turn this into a 10, so multiply top and bottom by 5. 5 times 7 is 35 over 10. So I'm showing less work there, right? I'm just actually doing the multiplication of that one that we're using, the special one. I'm doing it mentally. You can show it or do it mentally, whatever you're most comfortable with. 76 take away 35. 41? 41? Okay. Over 10. 41 tenths. Are we almost done? Oh, your favorite, number 5. You love word problems, right? Sure you do. Why is it always Sally in these word problems? Sally sold candy by the pound. The first person who came into her store bought 2 1/8 pounds of gumdrops. Really? Who buys gumdrops? All right. The second person who came in the store bought 5 3/8 pounds of jelly beans. How many pounds of candy did Miss Pearl sell to her first 2 customers?
I think the question should be, what is Sally's first and last name? Sally Pearl.
Well, we're assuming that Sally is Miss Pearl. Maybe it's a trick question. Maybe Miss Pearl isn't Sally.
The answer is 0.
Say what you should say is Miss Pearl got fired for stealing candy the other day, so she didn't sell anything. Something like that, right? All right, let's do the math. Come on. So we're doing 2 1/8. We're going to write that as a mixed number, right? 2 1/8. And the operation here is what? Addition. 5 3/8. What is this converted over to mixed numbers? 17/8 plus. I said eighths. Sorry. 17/8, right? Plus 43/8. I said it right, didn't I? Okay. Yes. So what I was getting at, though, is you just have to be careful with that when it comes to subtraction. And because subtraction gets really confused, it can be very confusing if you try that method with subtraction. So since we all kind of, you gave me the impression that you just wanted like the way it's going to work, this will work every time. No danger in this. If you like, I can show you an example of how you could get into trouble with it. No? Okay. All right, so 17 plus 43. 60 over 8. That reduces. I know 2 goes into each of those. And 4, so 4 goes into 60 how many times? 15. 4 goes into 8 twice, right? Now, 15 halves is the answer in an improper fraction. But if you wanted to put it together to make sense maybe in pounds, you would go to the improper fraction now, or to the mixed number. What would it be? 7 and a half. Right, 2 goes into 15 7 times with 1 left over. So 7 halves. 7 and a half. 7 halves. 7 and a half. I can't stand mixed numbers. Pounds.
So are you going to count off for not putting pounds and all that? The word problem? I need to know. I'm serious.
Then yes.
Okay.
You asked.
No, I want to make sure.
Yeah. Okay. Yes. All right. No, I understand that. If it's a word problem, we want to be able to interpret our answer and that it makes sense to us. Like, what does that quantify? The pounds of candy, right? Total pounds of candy that were sold. Carol's new dog weighs 127 3/4 pounds. Her friend's dog weighs 94.5 pounds. How much more does Carol's dog weigh than her friend's dog? No? No? What's the operation here? Subtraction. We're going to subtract one of these from the other because we're trying to find the difference between their weights, right? Which one goes first? The bigger quantity. So I'm going to write 127 3/4. Take away 94 1/2. I heard calculators. Yes. What do we have here? We're going to do it the way that we're going to follow a method here. 127 times 4 plus 3. 511 over 4 minus, okay, 94 times 2 plus 1. 283. Is it? 188. 188. 189. Are we, let's see, are we all okay with that? Okay. I'm following your lead. 94 times 2 is 188. Then add 1, 189, over the denominator 2. Forgot the 1? Okay. Now, common denominator between these. 4. So I just have to multiply the top and bottom of this one by 2. So 2 on top here, 2 on bottom there. I kind of squeezed it in. So 511 over 4. What is it? So what are y'all saying? 378 over 4. That's why it's important to have your calculator. You just have it sitting out. Do things like that on them. You double check. 511 take away 378 is what? 133 over 4. And now we need that converted back into a mixed number. So to do that one, I'll do it by hand because it's not as obvious. How many times does 4 go into 1? It doesn't. How many times does 4 go into 13? 3 times. That gives me a 12. I bring down like a 0 here. I have a remainder here of 13. 4 goes into 13. 3 times again. 12. 1. Oops. 1. 4 does not go into 1. So 1/4 here. So 33 1/4 pounds. Pounds, thank you. I said it, I didn't write it. You can do pounds this way or LBS. LBS is also pounds. Let's look at the last one here. On their vacation trip last summer, the Smith family got 30.5 miles per gallon of fuel on their trip home, on their trip from home. On the return trip, they got 17.78 miles per gallon. How many more miles per gallon of fuel did they get on their way out than on their way home? Who wrote this question? Math person. Math person wrote this question. It's subtraction, right? How many more? They want to know a difference. So we're going to take the larger of the two here, which was the 30.5. And we're going to subtract 17 7/8. Do that on your own. Get an answer. Is that right? Who's doing this already?
Yeah, but you can't subtract that. You're going to have a negative.
Yeah, common first. Got to make the first one an 8. Everyone got 143 over 8 though? Yeah. 17 times 8 was 130. Did you added the 7? 7. Hold on. Was it right? It's 143? Okay. Everyone assumes that math people are like automatic calculators. I was never an automatic calculator. Okay, now when I get my common here, I multiply the top and bottom here by 4. So 244 minus 143 over 8. 101 over 8. And then you do the mixed number, convert it, and what do you get when you do that? Is a fraction, yeah. 12 5/8. Okay, we'll leave it like that. 12 and 5/8 what? Miles per gallon. MPG? Miles per gallon. Mm-hmm. You could write miles per gallon in words. As a, you want an improper, as an improper fraction? Or you're saying leave it like this or go to a mixed? I would not take off for that. I would not. That's my natural bias of not liking mixed numbers. All right. We didn't talk about whether or not we were going to be taking a break in here or not. What do y'all think? Should we take a break in the middle? I mean, I know we're past halfway already, but what do y'all think about taking like a 5-minute break, like halfway through every class? Yeah? Okay. 5? 5, just to go out there and maybe just like breathe, take some water at the water fountain. I can break it up a little bit, you know. Okay. All right, so multiplication. Multiplying is easier than adding, right? When you multiply two fractions, you reduce first, then multiply straight across. That's the idea. So we're going to do this one first. Oh, I wanted to go back up here. I wanted to point something out on this. Notice that I wrote down the problem, then I put equals, and then what it turned into, and then I put equals, what it turned into, equals, what it turned into. Notice I carried an equal sign throughout. You don't want to just have these like splotches of work and then a number, and you want everything to logically go from one step to the next. Equals this, equals this, equals this. It's like asking you to write a paragraph and expecting that you use periods and exclamation points. Same thing here. You need to have the proper notation between your work. Okay? Work on that. Okay, 2 fifths times 10 is the same as 2 fifths times 10 over 1. I can rewrite 10 as 10 over 1 and then just multiply straight across. After I've reduced. Oh, I didn't reduce. Can you reduce these fractions? No. So multiply straight across and you get 20 fifths. Now can you reduce? 20 divided by 5 is 4. What about the next one? Reduce. 4/9 doesn't reduce though. What about 3/16? That doesn't reduce either. What do you mean reduce then? Are we talking about this? Oh, you mean reduce after we multiply? Maybe I'm lost on what I heard. Okay, so that's what I wanted to hear. So you cannot reduce 4/9 by itself, right? If that was its own fraction, that's not reducible. 3/16 is not reducible, but because this is multiplication, right? And only because it's multiplication, you are allowed to look across diagonally and reduce that way also. You cannot do that with addition and subtraction though. So you could say, how many times does 4 go into 4? How many times does 4 go into 16? 4 times. So what we like to do is cancel out the 4 and turn it into a 1, and cancel the 16, turn it into a 4. So I've reduced both of those factors by 4. But I can do the same thing with the 3 and the 9. 3 goes into 3 how many times? 1 time, and 3 goes into 9 how many times? 3. So really what I've done is I've turned this problem into 1/3 times 1/4. Y'all see that? This is a 1 over 3 times a 1 over 4. And when we multiply straight across here, we get what? 1/12. And that's it. We're done. What if you had not done that? What if you just were like gung-ho and just multiplied straight across first? You would reduce afterward. You would have gone 4 times 3, which would have given you 12. Then you would have done 9 times 16, which would have been 90 plus 54, which would have been 144. And so you would have had this, and you would have said, let me reduce that. What goes into both of these? 12. 12 goes into 12 once. 12 goes into 144 12 times. You would have wound up with the same answer. So you could do it both ways, but I think this was a little cleaner by doing the little reducing first. Okay, what about this one? Same thing. Let me try and reduce straight down first. What goes into both 21 and 24? Does something go into those? 3? How many times does 3 go into 21? 7. How many times does 3 go into 24? 8. How about the other one? 4 goes into both of these? No. 4 goes into 16. 4 times 4 goes into 28. 7 times. So I've reduced straight down. Now can I do any diagonal reducing? Yes. 7 goes into 7 once. 7 goes into 7 once. How about the 4 and 8? 4 goes into 4 once. 4 goes into 8 twice. Multiplying straight across, 1 times 1 is 1. Multiplying straight across, 2 times 1 is 2. 1/2. All right, quick poll. Yes or no on the last two examples? Yes or no? All right. Ooh, how do you multiply these wonderful mixed numbers? Same thing we did before. If you want to be safe about it, just change it. All right? So we convert this over. What, 2 times 5, 10 plus 4. So 14/5 times the next one, 41/8. Any recommendations now? Okay, we can, there's nothing vertically, right? 14 and 5 doesn't reduce, 41 and 8 doesn't reduce, but diagonally, the 14 and the 8 do reduce. 2 goes in both of those. So let's do a factor of 2 here. 2 goes into 14 7 times. 2 goes into 8, you said 4 times, right? That just makes our numbers a little smaller, a little easier to work with. Anything else reduce? How about the 5 and 41? No, can't do it. So we just multiply straight across now. 7 times 41. 287 over 20. Notice I'm boxing my answers. You should do the same. Y'all doing all right? We have an hour. Do you want a break before? You don't want to take a break or just keep going? Vote for a break. Yes or no for a break? It would only be 5 minutes. Oh, I closed the poll. Sorry. Vote again. All right. We'll do 5 minutes. We'll come back and do division. All right, so division. We're going to go through this faster because division is just multiplication written in a different form. So remember, in order to do division, you must change the problem from division to multiplication, then just do what we were just doing. We flip or invert the divisor, or the second fraction. Reduce if possible, then multiply straight across. So looking at this first one, 10 over 7 divided by 35 over 4. Could we reduce 10 over 7? 35 over 4? No, you can't do that. I mean, there's nothing to reduce. Could we go diagonally right now? You're not allowed to with division. You flip it first. Okay, that's the danger zone with division. You're like, 7 goes into 7 once, 7 goes in 35 5 times. Cannot do that until it's flipped. So I'm going to rewrite this first. So that's why we like to say flip first. Change division to multiplication, 4 over 35. Now you are free to try and reduce if possible. So anything reduce? 10 and 35. What goes into both of those? 5. 5 goes into 10. Twice. 5 goes into 35. 7. Now you can go straight across. What do we got? 8 over 49. That's the definition of division. Well, not because. Because if you have A over B divided by C over D, that is the same as saying A over B divided by C over D. Don't those mean the same thing? And what we can do is we can come in here and we can multiply this by D over C and then D over C here. So look at this D over C as being a 1. It's D over C is something over itself. This is a big 1, right? On the bottom, what happens is that you cancel out the C's, cancel out the D's, and you wind up just having the second fraction flipped. So it'll always work that way. All right, this one, flip first, 7/8 times what? 9 over 2 equals ... I'm not going to do it. I'm going to let you do it, all right, because of time. But you should get the answer of 63 over 16, which is 3 and 15/16. So you just multiply straight across. And what about this one? Flip first because it's division. Yes. Uh-huh. Yes, you can. But I just think it's a little dangerous to reduce before you flip, only because you might do it diagonally, maybe. But see, once you flip it, you can still reduce it. You can still reduce it. Was there something that went into both 18 and 42? What? 2? 6? You want to try 6? 6 goes into 18. 3 times 6 goes into 42. 7. So I'm reducing each of these by a factor of 6. And I can even go further. This 3 and this 9 reduce. Right? 3 goes into 3 once. 3 goes into 9 3 times. So I could go one further if I want. I think that's all we can do. When we multiply straight across, what do we have? 4 over 21. I'm going to leave number 3 to you. What? Improper, then flip. Yeah. Okay, I'll take you to the first step. You sure? 13/9 divided by 9/4. That's the first conversion. Convert these over, and then flip the second one and carry on with the same process. This will lead you to an answer of 52 over 171. Not showing the work there. Let you do that on your own. Okay, let's take a look at this word problem. In language arts, the class was assigned to write a team paper. Each team was to write 5.5 pages for the combined paper. When all the teams put their papers together, there was a total of 44 pages. How many teams had worked on this paper? You have total of 44 pages, 5.5 pages per team, right? So you're doing the total number of pages, which was 44, divided by how many pages did each team write? 5.5? So this is 44 divided by 11 halves. Does everyone understand the question? Yes? What did I do? Wait a minute. 8, 9, 52 over 81. Well, let me make sure I wrote this down right. I actually did not do anything but copy what they put out as the key. This is their key. So okay, let's see. Is it wrong? That's a typo in their key. All right. So the 9, these 9s don't cancel though, right? Flip it. Okay. Thank you for pointing that out. I will let the authorities know. The one that I don't do, right, is the one that has a typo on it. Okay. Does everyone agree with that answer? Okay. All right. Thank you for pointing that out. On this one, total number of pages divided by how many pages each team had to do turned into this. We need to rewrite 44 as a fraction. 44 over 1 divided by 11 over 2. Now what? Flip it. 44 over 1 times 2 over 11. Yes, always the second one. Yes, always the second one. All right. I want to multiply these across, but I'm noticing that 44 and 11 have a common factor of 11. You could avoid that and just go straight across and do 88 over 11, but you still need to realize that that reduces. So either way, I'll do 88 over 11. 88 divided by 11 is 8. So there should be 8 teams. So I'm writing out what the 8 represents, the number of teams. All right, Larry bought 12.5 pounds of candy to share with his friends. If he gave 2.5 pounds to each of his friends, how many friends did he share his candy with? Oh, Larry, what a nice guy. So what are we doing? What's the operation here? Division. What's being divided? 12.5 is being divided by 2.5. Equals ... meaning you could get that. So this is just a matter of interpreting the problem correctly. Once we get it to this, we've done a couple of these. We know how to convert this over. So the answer should be 5. 5 friends. Allison and her friend wanted to do something different. Wow. Okay. They decided to go to the track and see how many times they could run around the track without stopping. When they finally finished, their stopwatch showed they each ran a total of 23 2/5 minutes. If on the average, Allison also knew it took them 4.5 minutes to run around the track once, how many times did they make it around the track? So what they've given you is the total time, right, that they ran. And then they are telling you the time it took per lap, which is 4.5 minutes. So what is the operation here? What is it we're going to do? 23 2/5 divided by 4.5. Now, if you ever run into a problem like this and you're confused, which I think the wording is trying to confuse you, I always recommend you just change these into numbers that make a little more sense. Like change this into 20 and change this into, let's say, 2. So what if they were running for 20 minutes and it took them 2 minutes per lap? How many laps did they do? They did 20 minutes total, 2 minutes every lap. How many laps did they do? 10. How did you do that? 20 divided by 2. So you know from that sort of idea that all you're going to do is take that number divided by that number. I don't know if that helps you, but I've seen students in the past kind of change it to something easy first and then convert it back into the problem. So I'm going to take 23 2/5 and divide it by 4 1/2. And if you work through that, you should get 5 1/5. We might need to check that. 26 over 5 is correct. So that's 5 1/5. 23 times 5, 115 plus 2. So you get 117 over 5. Divided by 9 halves. Did you flip? So 117 over 5 times 2/9. 9 goes into 117. How many times? 113. Okay. So then you get your 16/5. 26, sorry. 26/5, which is that. And this is laps. Questions? All right. Moving on. Order of operations. So as you probably have been told, when we're doing math, we always have to be careful to pay attention to the order in which we do things. I'm on page 9. We all have to agree on a proper order to carry out our mathematical operations. If we do not agree on an order, then we can get different answers, which isn't good. For an example, let's say that we did this right here. What's the answer? So let's take a vote. You ready? I've heard the answer is being 1, or the answer is being 9. Any other potential answers? So let's vote on your little clicker, A and B, and go ahead. Everyone good? Some people aren't voting. That's okay. So we have roughly half the class each way. This is why order of operations is so important. Because if we do not agree to follow the same order, you can get two different answers, right? Some of you are getting 1, some of you are getting 9. So what is proper? Well, there's really only two things that you could possibly do here. You could do the 12 divided by 4 first. 12 divided by 4 would give you what? 3. 3 times 3 would give you 9. So that's the B people. 50%. Oh, now it's 50. I'm going to stop the polling. It was 50-50. Can't change your mind now. Then the other thing you could do is you could do the multiplication first. 4 times 3, which is 12. Then you would have 12 divided by 12, which would have been 1. So we have to agree on one answer. Thus, we have this thing, PEMDAS, which is our order of operations. I'll get back to the correct answer in a second. PEMDAS is a little acronym that we use to help us remember the order of operations. The P stands for what? You do everything in parentheses first. So this is the order that we do things. Always do, parentheses first. This could also include brackets or braces. Have y'all seen brackets and problems in braces? Brackets and braces and parentheses are all the same thing. They just group things together. You always do those first, or what's inside of those first. The next thing is what the E stands for? Exponents. Then M, D, A, S. M and D stand for multiplication division. Most people learn this, and they learn it exactly the way you look at it. Multiplication comes before division. In fact, 50% of you felt that the multiplication came before the division. If multiplication comes before the division, your answer would have been 1. That is incorrect. And that's why we're here. Because multiplication division is not done multiplication before division. It is done multiplication or division in order from left to right as you would read a book. Always. Okay? So this is going to be, okay, well, let me tell you again. It's from left to right. No. Left to right. Siri doesn't even know the damn order of operations. Get it together over there, Siri. Left to right. So multiplication does not have any priority over division. And addition and subtraction works the same way. It's left to right. Addition does not come before subtraction. But it does come after multiplying and dividing. So you must do the multiplication division first, then you can move on to the addition and subtraction. Well, after you've taken care of the exponents and parentheses. So, good. The correct answer here, because division and multiplication occur together, I read it from left to right. I do the division first, which is going to give me the 3 times 3 is 9. So the 9 was the correct answer. And I mean, that's good, right? Like if we're building bridges, which we're not, but if we were, you wouldn't want one engineer to get 1 and the other one to get 9. Be like, hey, well, I decided to do it this way. And, I mean, there has to be consistency. Question? No? If you type this into your calculator, it'll give you 9. It knows the correct order of operations. It knows them. It's programmed into the computer. Wow, what happened here? That is weird. All right, here we go. Some examples. Take a look at my equal sign. Equals. All right, this equals order of operations. First thing, what do we do first? Parentheses. So I'm going to do the 10 minus 2 is 8. So watch me rewrite everything. 5 minus 3 plus 7 squared 8. Now, I don't need the parentheses anymore because I already did what was in here, right? But I need to understand what was the operation between here and here. Multiplication, because there's no addition symbol, there's no subtraction. That's implied multiplication, so I'm going to put a dot. Okay, I've done parentheses. Now, we start the order of operations over. Do we have parentheses anymore? No. Next thing, exponents. Exponents are things to raise to powers. So I have 7 squared as an exponent. I do that first. 7 squared. 7 squared means 7 times 7, 49. So 5 minus 3 plus 49 times 8. And I continue, another equal sign. What's the next order of operation? Multiplication, division from left to right. I only have multiplication, right? It's subtraction, addition, multiplication. So I need to multiply these. 49 times 8, 392. 5 minus 3 plus 392. 394. Oh. What is it? 392. Okay. Oh, okay, gotcha. Now, the only thing left is addition, subtraction. I do it from left to right. 5 minus 3, 2. Plus 392. 2 plus 392 is 394. That's the proper way to do that. Nice equal sign, easy for me to follow. Hopefully that's easy for you to follow. Okay, what about this? What's that weird symbol? Square root. We treat a square root like a parenthesis. So we do what's in it first. Inside the square root, what do you see? Exponents and then subtraction between them, right? Subtraction. So I'm going to wait on the subtraction. I'm going to square each of these first. So this becomes square root. What's 5 squared? 25. Minus 9. Now what's 25 minus 9? 16. And the answer is 4. So here's something to be careful with, all right? 25 minus 9 underneath the square root. Sometimes I've seen students do this. Square root 25 minus square root 9. They decide that they're going to split this up into 2 square roots. What's the square root of 25? 5. Square root of 9? 5 minus 3 is 2. This is wrong. You have to do everything in here first. Then you do the square root. You are not allowed to split it up into 2. So correct answer is 4. Now, when we have division like this, what we want to do is visualize this as really being like a parenthesis up here, a parenthesis down there. You have to do everything in the top first, then everything in the bottom. Once you're completely done with everything on top and bottom, then you're free to divide. Understand? What's going to happen first on top? Inside the... So, no, there is a parenthesis here. You would look in there and you have a 4. But there's nothing you can do to 4. 4 is 4. So now you look outside, you have what? Multiplication between these two, right? Addition here, and then an exponent. The exponent has to come first. 7 cubed. 343. Plus 2 parenthesis 4. Over, on the bottom, can I just do 17 minus 3? Right? It's just 14. All right, what comes next on top? We add these two together? No, multiply 2 times 4 first. So that gives us 8. All over 14. which is 351 over 14. Wondering if that reduces. No? The only numbers that go into 14 are 2 and 7. So you could try, that's 2's not going to go into that. So you might just need to try 7, but 7's not going to work either. So this is fine. It's hard to read. I think that that's negative 3 times parentheses 5 plus 1 squared. So what are we doing first? Parentheses. Inside the parentheses, we have 6. So we have negative 3. How can I write this? Times 6 squared. So the squared is acting, the squared here is only acting on what's in the parentheses. The squared is not acting on the negative 3. So I need to square whatever was in here, which was a 6. Square that first, then I can multiply. So negative 3 times 36, that's 6 squared. And then multiply those two together. Negative 108. Why is it negative? Because when you multiply a negative times a positive, you get negative. What? Equals 2 plus 2 times. Can I do what's in this parentheses right now? Yes. 3 take away 6? Negative 3? Now, yeah, that's what I was going to ask you. How do you feel about this notation? We're doing 2 times negative 3. Should we put this in parentheses? I would. Only because you don't want to forget that dot and then think that that's really 2 minus 3, because that'll throw everything off. So instead, leave it in parentheses as a negative 3. I think that's the safest approach. Now what? What am I going to do? What's in this parentheses? But then inside there, there's another parentheses. Let me do this. I got to do the inner one first. So I've got to do the 1 minus 4. So watch how I just rewrite everything right now. I don't want to get ahead of myself. What's 1 minus 4? Negative 3. I believe I should keep that in parentheses still. And then all of that squared. It's actually very important that I kept this 1 minus 4 as a negative 3 in parentheses. Because I'm going to square, it's going to become positive 9. Which makes me think about this. What is the difference between this and this? Or is there a difference? Are they both 9? What does this mean? This means negative 3 times negative 3. This does not mean negative 3 times negative 3. This means negative, that negative out front is like a negative 1 times 3 squared. So you actually square the 3 first and get a 9 and then make it negative. So this is negative 9, this is positive 9. Major difference between the two. That's why it was so important right here that we keep the negative 3 in parentheses, because we're supposed to square whatever this is. So this is a negative 3, we're going to square it. That's going to give us a positive 9 here. I'm just rewriting everything. Now I'm doing 1 plus 9 squared. So I replaced negative 3 squared with 9, positive 9. I'm going to do what's in this parentheses now. 1 plus 9 is 10. And that's what, 10 squared? Now what about this minus that's in front of the 10? Is it attached, is it in here with it, or is it separated? It's separated. So it's not going to be negative 10 times negative 10. It's subtract whatever this is. So what is 10 squared? Because we're still doing exponents here. 100? My goodness, 2 plus 2 times negative 3 minus 100. So now we can do the multiplication. The multiplication is right here. 2 times negative 3 is negative 6. So we are now at this point. We have the 2 up front. We're going to take away 6. We're going to take away 100. Right? Because the positive 2 and negative 3 became negative 6. So that's why it turns into subtraction. From left to right, because all we have is subtraction. 2 take away 6. Negative 4 take away 100. Careful. Negative 104. You owe someone $4. You owe someone else $100. You owe a total of negative 104. So what would happen if you did all this work correctly? At the very end, you wrote negative 96 here. 8 to 9 out of 10 points, correct. I mean, I would give you a lot of credit, but I would need to see a lot of work, okay? If you're just going to like do all this in your head and throw an answer at me, if it's wrong, it's wrong. If you show me the steps, then I give you more credit. Because I know some of you are going to go on your calculator and just type all this in and hope, you know, you got all your parentheses correct. If it's wrong, I can't give you any credit for it. How about this next one? What is this straight line thing? Absolute value. Absolute value of a number is just that number positive. And we treated that absolute value as a parentheses. So we do what's in it first. In this case, there's nothing to do. Negative 8 can't simplify it. The 2 minus 3 I can simplify. So I have equals absolute value of negative 8 minus 9, and then what? Times what? Negative 1. So I better put in parentheses because it's multiplication. What comes next? Do the absolute value because it's like a parentheses. The absolute value of negative 8 is positive 8. So the absolute value goes away, right? Absolute value gone. Turns the negative 8 to a positive 8. Then I still have minus 9 times negative 1. What's next? Multiplication, these two. It's kind of two ways of looking at this. You can look at just, I can't cover it, right? But you can just do that. What's that? 9 times negative 1, which is negative 9. And then you could subtract it, which makes negative negative is plus. Or you could say negative 9 times negative 1, which is plus 9, or positive 9. Either way, you get the same result. I leave it up to you to determine what you like. In any event, it's 8 plus 9, which is 17. Wow, look at this next one. What did I say about this fraction thing? It sucks, yes. A fraction. It's like a parentheses. Everything up top is a parentheses. Everything on the bottom is a parentheses. You have to completely figure out what each one of those are individually before you do the division. So let's look at the top. 2/5 plus 1/3. So I come over here and I just kind of do it on the side. 2/5 plus 1/3. I'm adding two fractions. If I add two fractions, I have to have what? Common denominator. So I find a common denominator between those, 15. 6/15 plus 5/15. I multiplied this one by a 1. I use 3 over 3. This one, 5 over 5. Put those together, I get 21 over 15. You okay with that or not? No? Okay. What did I do? 11. Oh, yeah, I don't know why I got 21. I have no idea where I got 21. I mean, you can't get 21. Maybe I did, I don't know. 6, yeah. That's okay? Yes? Okay. Yes, it is. All right, next equals 1 plus. All right, so I finished doing all this up here, right? Which was 11/15 over, now the denominator here, 2 cubed. I can do that right now? 2 cubed is 2 times 2 times 2. 8. This is kind of weird looking. It's division, isn't it? 11/15 divided by 8. I want you to realize that that 8 is like an 8 over 1, isn't it? So this entire thing really looks like this. I'm going to write it on the side. 11/15 divided by what? 8 over 1. And I can look at that as division and turn it into multiplication, which would be 11/15 times 1/8. Flipping the second fraction over, which is 11 over 15 times 8. 80, what? 120. So this whole thing right here is 11 over 120. So I'm coming back over here. I'm going to write this in. 1 plus 11 over 120. Do you see how I'm doing this on the side over here? We call this scratch work, SW, scratch work. Well, I'm doing my scratch work over here, but I'm continuing my answer in here. I'm going from here to next step, next step. Anything I need to do on the side, I'm doing over here. It's a good habit to get into. What about this? 1 over 1 plus 11 over 120. How do you add these? Common denominator. 120 over 120 plus 11 over 120, which is 131 over 120. Yeah, it probably does. Let's see. Does something go into that? We're okay? Yeah. You have to keep it, keep trying until you're convinced. All right. That looks okay. Let me double check it because the key is not showing the same answer. So let me just double check that we did everything correct. 2/5, 1/3, multiplied 3 on top, 3 on bottom, 6, 5, 11/15, 11/15 over 8, 1/8, 11, 8. This was 80 plus 40 is 120. I don't see anything wrong. 131 over. Key says 146 over 11. 146 over 11. Ooh, did they? Oh, that's so wrong. Oh, no, no, no. No, no. This, I'll make my own test. Yeah, don't worry. This. No, no, this is not that teacher's. No, I'm sorry. No. That, it's kind of a little worse because this has gone through a couple of people. So, huh? It is A campus-wide, yes. Yes, I am on record right now. Yeah. So, hey, well, you know what? I mean, people are human. They make mistakes, right? Nobody's perfect. What about this one? Exponents first. So when I do my exponents first, wait, which one was I? I'm going to circle it so I can go back. Number 7 equals 48. 48 divided by 3 times 2 minus 16 plus 5.
So it's not -4 times -4?
Great question. No, why not though? No parentheses. No parentheses. The squared is only acting on its base, and if that base is 4 and doesn't have a parentheses or anything around it, then it's just the 4. That's like -1 times 4 squared. What's the next thing I need to do? Divide, right? Divide, I'm going to go left to right. So 48 divided by 3 is 16. I still have times 2 minus 16 plus 5. Now I do the multiplication. 16 divided by, I'm sorry, times 2 is 32 minus 16 plus 5. So 32 minus 16, 16 plus 5, 21. I see it. Where's this? Never mind. I see it. Let's see if we can get through the next page, which is, what, page 11, 12, and 13. Let's see if we can get 11, 12, and 13 the next 15, 20 minutes. I just don't want to put us in a hole too early in the semester where we're trying to catch up. I think we're all ready to go, but we'll hang in there. Okay, operations with polynomials. So now we start introducing the letters, the variables, right? And we start to have to combine things together. We have this idea of like terms. Let's see how much of this you already have in there. Adding, subtracting, multiplying expressions. So I'm going to do the same thing, order of operations. I look at this, I say, can I do anything in the parentheses first? Can I put these together? No, they're different. They're not like terms, right? I have X, Y, and Z, can't combine them. So I have no choice but to move on to the next order of operation, which is multiplication. I have multiplication occurring between the 3 and the X, right there. 3 times X is 3X. You can't really do anything with that. But then I also have multiplication happening here between this 3 and everything in here. Or you could say a -3 times everything in here. And so what we use is this thing called distribution, where you're multiplying the -3. It must pass through to each one. You all seen that before? So I'm going to say this equals my 3 times X, and now I multiply my -3 through. -3 times X is -3X. What's -3 times positive Y? -3Y. What's -3 times -Z? Plus 3Z. And at this point, the parentheses are gone. Now, I try and combine like terms together. To be like terms, you have to have the same variables. Those variables must also be raised to the same power. So notice that these first two terms have exactly the same variable, right? X and X. So I can just look at their coefficients. What's 3 of these? Take away 3 of these. None of them, right? They're gone. So these cancel. 3 take away 3. 3x's take away 3x's. So your final answer here is negative 3y plus 3z. Questions? How about number 2? Can you put anything together in this parenthesis? No. Outside, you got 2 times z, can't do anything with that. Minus 5 plus 3 times all this. So again, a distribution through. Okay, thank you. What the heck? The 3 is going to go through here. It's a positive 3 going through. It's going to go through and distribute to all 4 terms in the parentheses. Out front, I don't change anything. 2z minus 5. And now let's make sure we get the signs right. Positive 3 times positive 3x. Positive 9x. Positive 3 times negative y. Minus 3y. Positive 3 times negative z. Negative 3z. Positive 3 times negative 1. Negative 3. So just remembering, if they're the same signs, you multiply two things, same signs, it's positive. If they're different signs, it's negative, always. Does anything here collect together? Yes, we have a 2z here. We have a negative 3z here. And we have a negative 5 and a negative 3, don't we? And these are new projectors. They're pretty awesome. These colors are coming out great. On the, like last semester, we had these older ones, and they're like pixelating, and it looked terrible. You couldn't tell like the yellow and green apart from each other.
Okay, now I have a question.
Yes.
How you write the final answer? Because the way I was taught is you go through and pick out the ones you cannot change and bring those down first in your answer.
Mm-hmm.
Is that?
That's fine. There's nothing wrong with that.
Combining the things doesn't matter.
I'm not combining. I'm pointing it out right now. What's common? I haven't really put anything together yet. It's up to you. What do you want to write first? Do you want to write the stuff that doesn't change first? Okay, if you want to do that, it's not incorrect. It's not any more correct or less correct than doing the ones that combine first. So I'll do it that way. 9x minus 3y. I'll write those down. Those are the ones that didn't have any friends, so they're all by themselves. And then the yellow ones, the 2z, I take away 3z's. That leaves me with what? Negative 1z, or just minus z. And then negative 5, take away 3, negative 8. Now, we've already talked about the idea that most of you, this is it, like no more math for you, and that's okay. But I'll just point out that I do strike my z's. When I write a z, I strike it. Do you see it? I strike it. I do that to differentiate it from my 2's. Because my 2's and z's look a lot alike. So you can tell this is a 2 and this is a z. So please, if your z's and 2's look the same also, you might want to just do something a little different. I do a couple of things weird like that. My t's have a curl on the bottom, so I don't confuse them with plus signs. There's a bunch of things that are little, but again, if you were doing more math, I'd really like stress that you work on that. If you're not, then you'll make it, all right? Oh no. Is that a fraction? That's a fraction. All right, let's try and simplify what's in the parentheses first. Can't do anything, right? Nothing. That means we have the pleasure of distributing negative 3/5 through to each one of these. All right. I think I'll kind of take my time through this. What is negative 3/5 times 3x? That's the first one, right? That's the first multiplication through. How am I going to multiply negative 3/5 times 3? I look at that 3 as really being a what? 3 over 1. Look, there's more junk that I need to do. I'm just focusing all my attention right now on the first one. This is negative 3/5 times 3 over 1 x. So now I multiply straight across, right? Multiplication is straight across. What about the negative? It was out in front, wasn't it? Get off of there. I can't get that off of there if I come in from this way. That negative right there, that one, is it on the top or the bottom, or is it on both? We have, when you have negative 3/5, oops, negative 3/5, is the negative on the 3? Is it on the 5? Is it on both? If it's on both, wouldn't it be this? And isn't a negative over negative positive? So it can't be on both, right? It actually turns out that it's your choice. It can be on the top or on the bottom. It's your call. It really doesn't matter. So we normally put it on the top just as a convention. But think about it. Negative 3 divided by 5 is a negative answer, right? 3 divided by negative 5 is a negative answer. And they're the same ratio, 3/5, 3/5, just both negative. So when we see this negative out here, I'm going to treat that negative as being up on the 3. And then when I multiply straight across, it's going to be negative 9. And when I multiply across the bottom, it's going to be what? Positive 5, right? So we're going to have negative 9. I'm running out of room here. Negative 9 over 5x. That is just this first multiplication, right? That's this. That's what all this is right here. Right? And now I've got to do the rest of them. Now the rest of them aren't as bad until we get to the 5, because when we have a negative in front, it's like a negative 1. It doesn't change the 3/5. So tell me what the next one will be. So negative times negative is positive, so we get plus 3/5 y. The next one? Plus 3/5 z. And now the last one. What's a negative times a negative? Positive. So I know my answer is positive. What's 3/5 times 5? 3/5 times 5 over 1. What can you do with those 5s? Okay, or you do 15/5. 3. It's just 3 plus 3. Now, so my final answer is that negative 9/5 x that we did in the very beginning, plus my 3/5 y, plus my 3/5 z, plus my 3, box it up, and be happy. I'm afraid to check this. What do we get for? It's wrong. Yeah. We're almost done here. Let's finish up this last one. We'll say this is our last one for today, all right? So why don't you work that one out? See if you can get it. Let's do this. How about this? Do it on a separate piece of paper. Put your name on it. Let's turn it in. All right? I'm going to count it as something. I don't want to say it's a quiz, but it's a quiz. And make it, you can talk to each other, okay? That's okay if you help each other out on this one.
So just this number 4
Just number 4, put your name on the top. Put today's date. I just need name and date